Welcome to the Headwaters Science Center 3:30 show. Well, I'm in a vaccination bubble, so I'm going to pull this mask down so that I can get out there onto the internet a little clearer and cleaner. What are we doing today? Well, as the title suggests, we're going to be paying homage to Archimedes, probably one of the 5 greatest mathematicians of all time. I expect if he was around today, he'd still be showing us some mathematical elegance in some of the things he's discovered. But we're interested in Archimedes because it was a technique, and he made for a great story and even a term that's tied to him. So let's start with Archimedes. But first, introduce what we're going to do. We're going to talk about density, and Archimedes' story has to do with how dense was the king's crown. So we're going to show you how to do a density lab in class, and both the way it's done with fabulous, elegant tools and things as simple as a paper ruler and a triple beam balance, okay? So here we go. Let's talk about Archimedes first. Now, as the mathematician, he was given the task of finding whether King Hiram's crown was made of pure gold. Now, how was he going to do this? Now, in Archimedes' time, he knew about density, and the way he found density and they found density was much in the manner that we're going to do that afterwards. So we're going to start you out with Archimedes, present the riddle, and then we'll answer it by the time we're done with our show. So what Archimedes' task was to find out if indeed the king's crown, which was made by Arius Anvil, wasn't made of pure gold. The king, being a suspicious man, suspected that his goldsmith had pilfered some of that gold. And he thought perhaps he used silver in place of gold. Why would he do that? Well, as you know, gold is much more valuable than silver. In Archimedes' time, it was much more valuable than silver. Today, it's much more valuable than silver. I just checked the gold prices this morning, and gold goes for $1,763 an ounce, while silver goes for $22.66 an ounce. Quite a difference. Not much difference now than in Archimedes' time, but it is about 77 times more valuable. So Archimedes was tasked with figuring this out. Now, the king was a prideful king, and he told Archimedes that he needed to find out if the crown was pure without ruining the crown. For if Archimedes were to destroy the crown and it was made of pure gold, he would surely be thought of as a fool. But he was no fool, and he had Archimedes. So Archimedes did not have the answer to this riddle right away. He knew how to find density, as we will, and yet he was still stumped by this. So what did he do? How did he find this out? Perhaps you know. If you know, hold the secret, run the idea back through your mind. Tell a friend if you have to, but we will reveal the answer to the riddle when we're done and how he discovered whether the king's crown was indeed made of pure gold. So density is something that we're actually pretty good at figuring out. Now, I have a bunch of cubes here. They're all the same size, but made of different materials. This one is made of aluminum, and this one is made of copper, and it's real easy to feel how much more dense, massive feeling the copper is in my hand than the same piece of aluminum. But how do you actually figure out the density of those materials? And why is this important? These are the things we're going to try to figure out. Now, if you're running a classroom on a tight budget, a paper ruler can work. We can use this to measure a cube, and we know that the formula for the volume of a cube is length times width times height. So in my estimation, while I don't want you to see me doing mathematics, I found that this cube was 2.5 or so centimeters wide, high, and long. And so it was about 16. Well, I actually went accurately. It was 2.52 wide, 2.59 high, 2.56 long. So how did I figure out these things exactly with this tool? I did not. I used one of my favorite tools, which is the electronic caliper, and it tells you exact widths by squeezing it between here, and then I get both an actual measure on a tape, on a ruler, and then I get a digital measurement, 2.54 there. Again, different here. What I found, and it was a little bit off-putting, is that these cubes, I can see they're not manufactured to exacting standards, but I actually proved it with my caliper. This is a nice tool, not too expensive, maybe 20 bucks I paid for that thing. And so if I were to figure out the volume of that cube, and I did that square cube, the volume of the square cube was, and I've written it down here somewhere, was a little bit, I don't have that one on this paper. It's over in my other sheets. No, here it is. 54.1 was, no, 6.35 was the volume and 54.1 was the mass. I found out that the copper cube indeed came in within what I thought were the tolerance measures of mine, copper being about 8.92 grams per centimeter cube. It came out well, I showed it. Now, when we get to a cube, that's pretty easy to figure out. But when you get to something like these are called slugs, these round cylinders, there's where the caliper was a nice addition because I was able to find out the diameter of that. And then here it's 1.28 centimeters in diameter. I use one of my favorite formulas for finding the diameter of a cylinder, and maybe you can see it there. It's right here, which is the volume of the cylinder is pi times the diameter squared times the length divided by 4. And I was able to get a standard, and I kept my standard for all of these, which I considered one of these cubes, these standard ones I have, are about 6.35 cubic centimeters. So that was good, because if I wanted to find the density of, for instance, let's go to the copper one, since we're talking copper. I find the mass. Now you can use an electronic balance like I have. 56.9 is my number, and let me see that line for me. 57 I have here. Sometimes if you want to go significant digits, a lot of times you'll get all kinds of digits. You really can only go out as far as the accuracy of your tools. Of course, we're getting less accurate when we get down here. So as I multiplied those out, I was able to figure out with that cylinder equation that indeed, yeah, copper was the mass as indicated close to what I thought it should be, which was about 8.92 grams per centimeter cube. So that worked out nicely, and it was really interesting. Now, I've done this in classrooms where I make this into a riddle, and I do that by saying, well, look at these, they're all equal mass, but they're very different sizes. So you can do that with cubes that are different. They don't have to be perfect cube sets like I was so lucky to have for me in the Science Center, where we have lots of resource. So you can use other things you find. For instance, blocks are good. But the thing with a block is, if you get a block, it doesn't, it's much lighter, and wood tends to be a trickier density because the amount of moisture it holds can vary quite a lot from one block to another, and even from one day to another. But we all know that some wood is quite light. For instance, the pine is pretty light, but the oak starts to feel a little bit heavier. And when you get to these kinds of things, you'll see that oak's about twice as dense as pine is. Now, we still haven't said how Archimedes found out which one was made of gold. Let's move in on this. And where do we actually use this technique? We use this technique with rocks a lot. Let's look at this. Now, this looks interesting. Can the camera see that very well? How is that looking on camera? Is that gold? It speckles, it sparkles, perhaps it's gold. Well, how can we find out? This is actually gold or not gold. Let us solve the riddle to Archimedes' riddle with this piece. Now, how Archimedes found volume was by water displacement. And here's how we're going to do it. I'm going to put this piece of pyrite into the liquid, and just before we got here, I had topped this all the way to the top. And so when I put this in the water into my graduated cylinder, it will flow the same amount of liquid as the object takes up. Have you figured out how Archimedes found out the riddle?
Eureka!
Eureka! My camera person has, indeed. As Archimedes ran through the streets naked from the public bath, screaming, Eureka! Which means I have found it! he realized when he had overflowed his bath and gotten into it that it would reveal the volume of the item that he had. And in this case, there's about 7, well, let's try to get a close measure. I should flatten that out instead of hold it in the air. About 7 milliliters. Let's be real precise as we can. It's about 6.5 milliliters, which, by the way, why does this even work? This works because the metric system is actually built from water. Pure water, 1 cc of pure water weighs 1 gram. So this does work. So we've got about, what was my number again? I said, I'm going to look at it again. 6.7. I'm going to tool that in a little bit closer. Let's take this out of here again, because this is what we actually need to. Volume being what it is, it's not going to let me have any more volume in there. Oops, you didn't see that, neither did anyone else. And so I'm going to pull this out of here and measure this. Turn that on. So I have a volume in cubic centimeters, and I have a weight at 33.2. 3.2, and my volume was 6.7. Not to do too much mathematics on screen here, because mathematics is fun when it comes to a fruitious end. 0.2 divided by, I haven't done this, so I hope this works out. I like to keep a few things surprising. No, this is not the density. I got 4.9. That is not the density of gold. Gold's density is 19.32. It's only about 1/3 as dense as it should be if it were pure. And even if it were scattered through there, it's not quite going to make the mark. It's not going to quite do it. So, yeah, Archimedes found that out in his head because he knew if he took the same mass as the crown and it displaced less water than the crown, that he indeed had a crown that was not made as dense or as much with gold as was promised. Well, Arius Anvil was proven to be a thief, lost his head by the end of the week, and that story winds itself up with Archimedes going on to be the greatest mathematician perhaps of his time. Well, let us do some things that might surprise one. We all know that things that are lighter than water float, at least by the same amount of volume. That's, for instance, these pieces of wood, they're going to float. They float because they're not as dense as water. When your density crosses the 1 point, you become denser than water. So here's a rock that'll go down like or sink like a rock. So perhaps we would like to make a generalization saying, for instance, wood floats and rocks sink. You might be rushing the point. Here we have a duck, and ducks not only float, but when they're made of wood, they should also float. Do ducks float?
According to Monty Python.
According to our test, this duck does not float. There is one wood that does not float. Does anybody out there know what it is? Ebony and ivory. Here, I'm going to hand this to my camera person, keep it away from the electronics. Is that quite a heavy duck made of wood? While you can't verify it, he can. And we all know that rocks sink. Or do they? This rock, pumice, is floating. So while we can have some rocks that float and some wood that sinks, therein lies the curiosity and the marvel of science. Just when you think you know what you think, you got to think some more. So we'll let a sinking duck and a floating rock end our show today. And perhaps we'll go into this further next time, the way I actually prefer to find density with specific gravity, but we'll see. We'll go there next time, perhaps. That's the end of our show today. Don't cheat the children of their labs. Those of you that have to come in and tune in at 3:30 to find out, we're going to keep these labs coming at you and keep on going. So if you want to come on down to the Headwaters Science Center, Monday through Saturday, 9:30 to 5, Sunday 1 to 5. Well, we'll talk about density if you want. We'll talk about biology if you like. We'll talk about